In this example, we want to show that the inner product of functions, continuous functions f and g, defined by the integral from 0 to 1 of f of x times g of x dx is an inner product on 0, 1. Okay, well, we need to show our four properties. The first one, that the inner product of f and f is greater than or equal to 0, and that the inner product of f and f equals 0 only when f is 0. Second property we want to show, that the inner product of f plus g with h is equal to the inner product of f and h plus the inner product of g and h. Third, we want to show that the inner product of alpha f with g is equal to alpha times the inner product of f with g. And finally, we want to show that the inner product of f with g is equal to the inner product of g with f. Okay, so these are the properties that we need to show. These are the properties of inner products. So, for property 1, the inner product of f with itself, based on the definition given here, is the integral from 0 to 1. So the first component is f. So here it's going to be f of x. And the second component, here is g, here is f. So f of x times f of x dx. So that's the integral from 0 to 1 of f of x squared. And of course, because this is greater than or equal to 0, because it's squared, this thing is always going to be positive on 0, 1. So this is greater than or equal to 0. And in fact, we can say more, that the only time that this is ever equal to 0 is when f is equal to 0. Because anytime f of x is different from 0, this gives us a value that's non-zero squared, which gives us a non-zero area under the curve. So property 1 is satisfied. How about property 2? Well, the inner product of f plus g with h is the integral from 0 to 1 of f of x plus g of x times h of x dx, which is the integral from 0 to 1 of f of x h of x plus g of x h of x dx, just by expanding out that bracket. And this is equal to the integral from 0 to 1 f of x h of x dx plus the integral from 0 to 1 of g of x h of x dx. And this first guy is the inner product of f with h. And the second guy is the inner product of g with h. Oops. Which means property 2 is satisfied. Property 3, the inner product of alpha f with g is equal to the integral from 0 to 1 of alpha f of x g of x dx. You can probably see where this is going to go right away. We'll pull the alpha out front of the integral. And this is the inner product of f with g. So this is alpha times the inner product of f and g. So property 3 is satisfied. And property 4, the inner product of f with g is equal to the integral from 0 to 1 f of x g of x dx. And of course, this multiplication can be done in any order. So this is the integral from 0 to 1 of g of x f of x dx, which we also know is the inner product of g with f. And so because all 4 properties are satisfied, this integral is indeed an inner product.